This is Sakshi and I welcome you all to my Tech platform, Way to Learn. So we are going to solve PYQs and we have already solved 3 PYQs from June 2011 from thermodynamics. And so let us see today's PYQs from December 2011. And so this is the first question, which is a very easy question. You just have to know what formula to use. Okay, so the internal energy E of a system is given by E is equal to Vsq by Vn, where V is constant and other symbols have the usual meaning, that is V is volume, N is number of particles, and the temperature of the system is equal to. So here E is given, right? Internal energy is given and temperature is asked. So basically, you'll have to remember what are the formulas that you know. Okay, so in my last few videos, I have given you some of the tricks to remember some of the formulas. And so one of the formulae was to determine the parameters pressure, volume, temperature, right? So we are going to use that. We have to find the temperature of the system. So we are going to basically use that formula to find the temperature of the system. So this is the trick over here. So, we used great physicists that have studied under very fine teachers. Okay, I have taken the corner terms inside and now I have to find the temperature T. So, my temperature T goes to H and goes to U. U here is the internal energy. And it goes to H and U with respect to S. Right? So, T will be equal to dou U by dou S at constant volume. And again again T will be equal to dou H by dou S at constant pressure. So this was the trick to remember the temperature formula. Now you have two temperature formula, but you have to think what is the correct temperature formula you have to use here. So here in the question you have internal energy, which is given in terms of E. So you have internal energy, then you are going to use this first formula at constant volume. Okay, so you'll have to remember constant volume or constant pressure. So here is a trick to remember constant volume or constant pressure. So here U is equal to Bs cube by Vn, right? Now you'll have to find T is equal to dou U by dou S and constant V. Now you'll have to find du with respect to, you're going to differentiate du with respect to S. So now when you differentiate, you get 3Vs squared ds by Vn. You're not going to differentiate the volume because it is constant. Okay. Now you need dou u by dou s. So dou u by dou s will be 3bs square by vn, which is equal to option B. So very simple thing. You'll have to just remember what formula to use. Okay. And basically I have also given like how if you have to find temperature, volume, pressure or entropy, then you can use the following tricks to remember those formulas. Okay, so if you do not know the tricks to remember, please go to my last 3 videos of thermodynamics. You'll have like 4 set of problems to remember, which are very important for you to solve the problem. Let us see the fifth problem of the session. Okay, so consider Maxwellian distribution of the velocity of molecules of an ideal gas. Okay, let VMP and VRMS denote the most probable velocity. So VMP is the most probable velocity and VRMS is the root mean square velocity respectively. The magnitude of ratio VMP by VRMS is. So we know the formulas for VMP and VRMS. So we are going to just use the formula and then find the ratio of them. So VMP is basically root over 2 kBT by m and VRMS is root over 3 kBT by m. You are going to find the ratio of VMP by VRMS. So you get root over 2 by 3, which is equal to option 3. So very simple. You have to remember the formula for VMP and VRMS, and one more thing is V mean. So if you remember those three, that will be a pakka question for you. If you have that kind of question in GATE or NET, then you just need to find in you can just find the answer in very few seconds, right? Only you'll have to remember those formulas. So you have to revise those formulas on daily basis or at least in 2 days once, so that you remember those formulas, how to solve them and how to memorize the tricks, and just write down every week. Okay, write down all those formulas every week, or at least try to memorize or try to just tell someone all your formulas. Okay, so that will be helpful for you in order to remember all these formulas. Next, it's again from CSIR December 2011, and here the excitation of a 3D solid are bosonic in nature. Okay, and with the frequency omega and May number k are related by, okay, here the relation between omega and k is given, which is omega is proportional to k square, and in the large wavelength limit. Okay, if the chemical potential is zero, okay, the behavior of the specific heat of the system at low temperature is proportional to. So I have to find the specific heat of the system at low temperature. So here's a trick for this question. Here we have a relation between omega and k. So omega is proportional to k squared. So the trick is here, if omega is proportional to k power s, then Cv at, that is specific heat at low temperature, will be given as T power d by s. D here is the dimension. So in the question you can see that it is a 3-dimension solid. So d will be 3 here and s will be 2 as given in the question. So specific heat will be T proportional to T power 3 by 2, which is option C. So I hope you understand this session, the three questions that we have solved along with the formulas. So the main thing, important thing here is for you to remember the formula. And if anything is new for you, then just write that in your formula notebook and revise them on daily basis. So see you tomorrow. Thank you. Like my videos, share my videos, subscribe my channel, and do not forget to hit the bell. So see you tomorrow with more videos and more questions to solve, and so that we get a command on thermodynamics, which will be helpful for our next session of net exam. So see you tomorrow. Ta-da!